Okay, good evening, everyone. Sorry about the technical glitch in getting going. There were some problems with the internet, and we've managed to resolve that. Like to welcome you all this evening for, I think it's our third or fourth YouTube live talk for ArchSoc. This evening, we're lucky to have Romala Govender from Iziko. She's a paleontologist, and she began her paleontology career studying Karoo paleontology and obtained her MSc in 2002, studying the Permian dinocephalian postcranial anatomy of Tapinocaeninus pameli. I hope I'm getting all these pronunciations correct. And her PhD in 2006, studying Triassic Diunatans postcranial anatomy, focusing on Canamaria, Semocephalus at the University of the Witwatersrand. After completing a postdoc fellowship at the Bernard Price Institute for Paleontological Studies in the ESI Institute in 2008, she began a postdoctoral fellowship at the Biological Sciences Department with Professor Anasuya Chinsami-Turan at the University of Cape Town in 2009. First funded by the department and then by the Claude Lyon Foundation, where she began her study of Mio-Pliocene fossil marine mammals. This project focused on the fossil marine mammal fauna from Langebaanweg. Currently, she is curator and scientist in the Cenozoic Paleontology Iziko Museums of South Africa and honorary research associate in the Department of Biological Sciences at the University of Cape Town. Her research has now expanded to focus on the Mio-Pliocene fossil marine mammals from the west coast of southern Africa, to understand the marine mammal constitution and the environment, as well as the changes that have occurred in both over the past 5 million years. In January 2020, she obtained her NRF-C rating. So her title this evening is How the West Was Changed, Late Mio-Pliocene Marine Mammal Fauna from South Africa's West Coast. And along the west coast of South Africa's marine paleoenvironments, which changed from the late Miocene to the early Pliocene. There were embayed areas, lagoonal, estuarine, and rivers. The Benguela Upwelling System was well established and supported a rich seal and cetacean fauna. The phocid true seal, Homiphoca, was analyzed using landmark morphometrics, which showed that there were 3 or more seals living off the coast 5 million years ago. The seal's home range extended into the Northern Cape, and they were capable of switching between feeding regimes, possibly affected by season and food availability. And there's evidence of breeding colonies in the Langebaanweg area during this time. The cetaceans from the west coast are related to cetaceans from the Mediterranean, North Sea, North Atlantic, North and Southeastern Pacific. The presence of young cetaceans suggests that there were potential breeding areas along the coast, which was possibly frequented by cow-calf pairings as well as other young animals. This may be linked to the presence of estuaries and lagoons along the coast. So I'm looking very, very much to this talk, and sorry again for the delay in getting this out to you guys. And some of you have the Google Chat feature on the right-hand side of the talk, and you can send us your questions throughout the talk, and I'll collate those at the end, and we'll put those to Romala at the end of her talk. But without further ado, Romala, I'd like you to take over. Welcome.
Good evening, everybody. Thank you for the opportunity to tell you about some of my interesting research. Just quickly, this is the breakdown of my talk for this evening. So a little bit of an introduction, something about South Africa's localities, and then we'll move on to the important things of the Mio-Pliocene marine fauna, as well as some of the taphonomy related to these animals. So during the late Cretaceous and the early Cenozoic, Africa started moving northwards. Southern Africa became separated from its Gondwana neighbors. And during this time, as it became separated, you had the opening of Drake's Passage, the Tasman Sea, the Greenland-Scotland Ridge, and you had the closing of the Panama Isthmus, the Tethys in the Middle East, and the Indonesian Gateway. And we also see a drastic change in weather and climate during the Cenozoic, from pretty warm, ice-free, to large ice sheets in the northern and southern hemisphere during the Mio-Pliocene. But what is also interesting during this time, as you can see here, the circumantarctic current became established, which meant that Antarctica became thermally isolated. And this meant that the ice sheets of Antarctica began to expand. And this in turn began to affect the environments further north. So at mid latitudes, you had increase in aridity. And by the middle Miocene, you had the Namib and the Atacama deserts form. Also, along the west coast, you had the Benguela Upwelling that started to establish itself. And this is identified by a change of warm water nanoplankton being replaced by cold water forms. Now, these are some of the localities highlighted with the red stars. But firstly, the southern African west coast is over 2,000 kilometers, and it is divided into three regions that are recognized to have Cenozoic deposits. So you have the southwestern Cape between Cape Town and the Olifants River, Namaqualand between the Olifants River and the Orange River, and Namibia to the north. Although we have very few onshore deposits in these areas, where they do exist, they're actually very rich in paleontology and archaeology. Also, these deposits are not just onshore, but they're also subsurface deposits. So they occur in boreholes. And the environments that they show is meandering rivers during the Mio-Pliocene, between the middle and late Pliocene. And we have rivers, estuaries, um, shallow marine, deep marine, and terrestrial deposits also present along the coast. Also interesting is that, as you can see, these two pictures show you the different positions of these sites during the 50-meter high and the 30-meter high. So the Hondeklip Bay material is known as the 50-meter package, and that's the one we're interested in because it dates to the same time as Langebaanweg, which is between 7 and 5 million years ago. So that's between the late Miocene to the early Pliocene. And Langebaanweg, as you can see, is in different positions during the 50-meter high and the 30-meter high. And its deposits were laid down during the 30-meter high. What is interesting about these areas is that Langebaanweg is today 13 kilometers inland and less than 2 degrees north of the southern tip of Africa. 5 million years ago, it was less than a kilometer from the river mouth, and it has a large, diverse fauna present. Also, it has been brought to our attention through the phosphate mining that began at the quarry in 1965. At Hondeklip Bay, we have a similar situation where diamond mining opened up trenches where fossils were found. These fossils were related to marine areas of lagoons and areas with offshore islands. Today, Hondeklip Bay is 1.5 kilometers from the current coastline. Koeberg is a subsurface locality that was found during the digging of the Koeberg power station foundations. And what is interesting, this locality is actually 12 meters below the current surface, and more than likely during the Mio-Pliocene was actually offshore. So, on to the things I'm here to tell you about. A little background into why these marine mammals are interesting, because they haven't been studied in much detail, and they have been giving us a lot of information about Africa's relationships to the rest of the world with areas of similar age and similar animals. So during the late Miocene, the coast of South Africa, or Southern African west coast, was embayed. So there were a lot of coves and things like that. It was also covered by sandy as well as rocky beaches. We do have fossils from this time period, but as you can see, as I've tried to illustrate with this picture, lots of them are broken, damaged, and rolled, mainly fragmentary. And what that does tell us is that they were affected by wave action. As you can see here, I've tried to illustrate the point where they probably were lying on the beach, and as the waves were coming in, they were being rolled. Moving on to the latest Miocene, and I'm now going to specifically look at Langebaanweg because it's one of the richest faunas during this time period. We had the Proteauberg River, which wound its way down to the ocean through an estuary. Along this river are a number of lag deposits that have been excavated that have produced this rich fauna. And as you can see from the picture, up here is Agrotherium, which is a short-faced bear. In the bottom corner, you have a giant wolverine. There's also a giant otter. We have three types of elephants. So we have Gomphothea, which is a four-tusked elephant. We have Mammuthus, which is the ancestor of the mammoth. We also have Loxodon elephant, which pushes the ancestry of modern elephants into the Mio-Pliocene. There are also three types of giraffes. Cibothea, which most people know about, which is a short-necked longhorn giraffe, a modern giraffe, as well as an okapi-like giraffe. There are also a number of saber-toothed cats, a three-toed horse, hippos, and all kinds of birds of prey, from eagles to vultures to falcons to owls, as well as parrots, uh, parrots, woodpeckers, flamingos, and a swan. So here we have a place that was rich and diverse and was able to support a variety of animals. Also, in and amongst all of this are the seals. Now, a study of the mollusk fauna from Langebaanweg actually showed that there was an interesting change. So they have the presence of fresh water, marine, as well as estuarine forms. They also found that the preservation of these mollusks varied from being complete to partially damaged to completely fragmentary. And what this suggested that this system passed from a river to an estuary to a lagoon. But the interesting thing is that this lagoon is actually open to the ocean but protected at the same time. And what this means is that we also have a place where you can have young animals and pups. And we know that these specimens appear in our collections, and it suggests to us that there are breeding colonies in this area. Later in the earliest Pliocene, we see a slight change where we have more granitic offshore islands. There's still a sandbar offshore because we know that this particular deposit was deposited between the shore and a sandbar. But there were a number of islands surrounded by shallow water, which made them easy haul out sites for the animals to live. It also allowed them to breed. And as you can see, what could happen as well as we sometimes have animals that would become beached and eventually die and end up lying on the beaches. As you can see here, I've put in a couple of pictures to show you just what our young animals look like. So you have the femur of a pup and the ilium of a pup, as well as in the background here, you have the humerus shaft of a cetacean. So today, the South African coastline, or really the Southern African coastline, is dominated by a single seal, an otariid seal or eared seal, given this name due to the external pinnae present on its ear. They extend from Algoa Bay on the east coast all the way to Cape Freo in Namibia, and have both onshore and mainland breeding sites. And this covers over 3,000 kilometers. Now, 5 million years ago, this was a very different story. The seal that lived here is a phocid seal or a true seal. And the difference between a phocid seal and an otariid seal is that a phocid seal does not have the external pinna on its ear, but rather its ear hole is actually covered by a membrane, and it's unable to turn its flippers forward and walk on land. It rather has to wiggle to be able to move on land. So having looked at the seals and having looked at the skulls and the postcrania, I noted anatomical differences. But we needed to quantify these differences. So we undertook a study using 3D landmark morphometrics, which would allow us to analyze the Langebaanweg skulls compared with modern skulls. And because of the type of seals we think they are, we have included in that study Leopard seals, Weddell seals, Ross seal, and the crab-eater seal, as well as the Mediterranean monk seal, the Hawaiian monk seal, and a harbor seal, just so that we were able to include the other family represented. And what we found was very interesting. The current picture you're looking at tells us something about the shape of the skull of these animals. So what we can see from this is that the extant taxa actually have very homogeneous skulls. And I say this because we had adults, we had juveniles, and we had pups. We also had males and females. So what this tells us is there's very little difference in the way their skulls grow and their size. But all the red stars you can see actually belong to Homiphoca. That is the currently recognized genus of phocid seal from the Western Cape. And as you can see from that, they are very widespread. They're telling us that there's a difference. And because we know that the extant seals have homogeneous skull shape, we can actually infer that this difference that we're seeing may well be taxonomic. So what's the next step? So the next step is to have a look at the relationships of the Homiphoca seal skulls. So as you can see, we have the skulls labeled here, LBW A to E, with C being the holotype. And as you can see here, it is where we expect it to be within the Lobodontinae, so that is the Antarctic seals. So where we expected to find them, we find them related to the Antarctic seals, but most interestingly, based on anatomy, we expected to find it closely related to the crab-eater seal, but actually it comes out more closely related to the Ross seal. Now, there are two problems with this result. One is that the holotype skull is actually incomplete posteriorly, so we only have the front of the skull. And secondly, this analysis only looked at cranial features. So in order for us to get a better understanding of the seal's relationships, we need to actually include postcranial skeletons. However, this is difficult because we have 3,000 elements in the collections, but they occur as isolated elements. So one of the ideas that came out of this is that this may actually be telling us something about the animal's feeding behavior. Is it telling us something about their cranial anatomy related to food and feeding? We don't know. What we would like to do is actually get a complete picture and to be able to split these relationships up so that they make sense and they are effectively telling us that there really are 6 seals living off the coast. In order to do this, we've begun new excavations at Langebaanweg in order to, with the hope we'd find some associated crania and postcrania. That story is still to be told as we're yet to find it. So the thing about phocid seals is that they live their lives in water. They interact with each other mostly in water, and we actually found a number of pathological changes to the skeleton. So what we have here, and you'll have to take my word for it, is a distal end of a humerus. But as you can see, that the articulating surface has been obliterated, and this is due to damage to the surface where bone has grown excessively and then been reabsorbed. So you have these little channels. And osteoarthritis is the type of disease that actually affects a single joint. This is the articulating surface of a tibia. And as you can see again, we cannot actually tell what the articulating surface would look like. There is a lot of bone growth as well as reabsorption of the bone. But what is really interesting about this specimen, as you can see circled, is that there is a bony plate on the medial side. And what potentially happened here is that this animal actually dislocated its femur and it was not able to get it would not naturally move back into its original position. So the body compensated by laying down bone to prevent it moving any further. What is also interesting is that we know these animals did not survive to a point where the cartilage wore away between the bones because there is no polishing of the bone surfaces. So these animals probably died quite young. Here we have a fractured ulna. And this ulna, as you can see here, there's two pieces of bone. So when this bone actually broke, the surrounding muscle actually went into spasm and it shortened the bone. So the bottom end of the bone moved back behind the top end of the bone. Now, the animal survived, and we know this because we can see healing happening here. And my honor student, Megan Woolley, who I co-supervised with Anusia Chinsami-Duran, looked at these bones again using CT scanning and histology. And she also came to the conclusion that the animal had actually survived for a year before it died. However, we can also see there is what they call traumatic arthritis or rheumatoid arthritis also starting to develop in conjunction with the fracture. This animal probably survived because, like I said, phocid seals tend to live their lives in water, and it didn't need to be moving about on land, and water buoys it up anyway. Here we have a pelvic girdle. We're looking at the right-hand side. This animal, as you can see, has a lot of periosteal reaction. There's also a lot of channels where bone's been reabsorbed, and you've got exostoses where the animal has laid down bone. But this animal probably suffered from my osteomyelitis. So there's no indication on the bone what may have caused this. But one scenario could be that the animal was actually in a fight or got in the way of another seal and actually got bitten. So the bite probably broke the skin, injured a muscle, infection set in, and this later worked its way through to the bone. And this does occur bilaterally in this specimen. Here we have a metapodal or a foot bone. And when I originally studied this bone, I was convinced it was a fracture. As you can see, the bone looks slightly skewed at the one end, and we have bone being laid down, which suggests that it's being knitted together. However, Megan re-examined this bone using CT scanning, and what she actually found that there is no traumatic injury to this bone, but rather that it probably represents an osteosarcoma or primary bone cancer. So while studying the Hondeklip Bay material, we came across a mandible, and after studying it, I identified it as Homiphoca, which is what we currently understand the phocid seal that lived off South Africa's coast. And what I found was that I could actually maybe hypothesize about its feeding regime. Now, we know seals use 4 types of feeding regime: suction feeding, filter feeding, grip and tear feeding, and pierce feeding. Now, when you have a look at the incisors and canines, which you can't really see in this picture, but we see wear facets very similar to that you would see in leopard seals today. And this would suggest that Homiphoca was actually capable of using its incisors and canines to pierce its prey and hold on to it. So it was capable of pierce feeding, similar to the leopard seals. But when you have a look at its post-canine teeth, you can see they interdigitate, they have high crowns, and the spaces between them are not equal. What this also tells us, and also you can see accessory cusps here. They're not that well developed as you see in leopard seals and crab-eater seals. But what it does tell us that Homiphoca was capable of some kind of filter feeding. What this would suggest that this animal, like leopard seals do today, was capable of switching between feeding regimes. Therefore, it allowed it to extend its home range into the Northern Cape, some 430 kilometers. Also, we have no evidence of breeding colonies at Hondeklip Bay, which suggests that off Angola, Namibia, and South Africa today, there are islands where young adults, so those that aren't sexually mature, even adults that are sexually mature that aren't able to find breeding partners, end up living on these islands until they're mature enough or big enough to move off to areas where they can breed. Okay. So the cetaceans, I'm going to keep this rather general because otherwise we get a little bit too technical and I don't want to bore anybody. So currently we have 9 mysticetes. So we have a right whale, a pygmy right whale, and 7 balanopterids. So these are all baleen whales. There are 3 sperm whales. There are 9 beach whales that either visit or are resident here. We have 15 dolphins, which are nearshore or pelagic, and a single porpoise. Now, about 5.2 million years ago, we had 20 mysticetes and only 18 odontocetes. Of that, we have balanids, which represents, and this is unpublished material, so it still remains to be clarified, but we currently potentially have a right whale and a pygmy right whale in the collection. But also we have an unidentified balanid, which requires further analysis to determine whether or not it is a bowhead whale. There's also a grey whale at Hondeklip Bay, as well as 16 other balanopterids. Now, but what is interesting, bar the right whale and the pygmy right whale, most of these mysticetes or baleen whales are actually extinct. We have 5 sperm whales present in the area at the time, 2 of which are giant raptorial sperm whales. There are 10 beaked whales, and these mostly come from offshore. There are 2 dolphins and 1 porpoise. So amongst the porpoises, very similar to today where we only have 1 present. However, today there are more odontocetes present than there are mysticetes. So something we also want to try and understand are what changes occurred that allowed these faunal turnovers. Because like with the seals, you see today, we have no phocid seal present along the coast. We only have otarid seals. So we need to understand what it is about these animals that led to the changes. So just quickly, by looking at the biogeography of the cetaceans, one of the interesting things is that South Africa shares a lot of taxa with other areas in the world. So we share a balanopterid with the Mediterranean, potentially 3 new species of the same genus. We also share 2 genera with the North Sea, 2 of which are new species, 2 potentially represent the already named species. We share a balanopterid with the North Atlantic, and we also share porpoise with Peru, so the Pacific Ocean, and we share at least 2 sperm whales, and these are giant raptorial sperm whales with Peru as well. So what makes Langebaanweg and Hondeklip Bay particularly interesting is both areas, and I'm just showing you this again, have lagoons with deep tidal channels that allowed mother-calf pairings and even juveniles easy access and exit. That means animals that were traveling along the coast that got tired or needed a break could easily access these areas to stop and refresh and then continue. But it also allowed place for injured animals to spend time to recuperate. As we move further along, there are a number of islands off the coast as well, as you can see here. And these embayments and lagoons also served another purpose in that lots of carcasses would have got washed in and probably didn't get washed out again, which meant they actually became deposited on the beach. As you can see, the beaked whale there has become beached. But what does this mean for Langebaanweg and Hondeklip Bay? So what actually happens to a whale when it dies at sea? So one of 3 things can occur. It can sink to the ocean floor and remain there. It can also sink to the ocean floor. Abdominal cavity fills with gases as the organs decompose. And the third thing that can happen if it has a high blubber content is that it can remain afloat. Now, what is interesting is that when these animals are leaching bodily fluids and floating around, they can attract sharks from as far away as 10 kilometers. So how do sharks feed? Sharks use different parts of their jaw to feed. As you can see here in the first picture, it's using the side of its jaw to bite into the flesh. And in the other picture, it is using palatal quadrate protrusion. So it actually projects its jaw out of its mouth in order to be able to take a larger bite, which includes flesh and blubber. The point of this picture is actually to show you here is that sharks tend to focus on the head of the whale to begin with because there is a meat-rich, thick tongue which they focus on. It also means that the head is the first part of the carcass to become detached and sink and become deposited. And the reason I'm telling you this and emphasizing this is that we have two jaws at Langebaanweg, which are fairly complete. But the most interesting thing about them is that they are covered in all directions in shark tooth marks. So I'm going to show you some of the damage I identified. So here we have what we call type 1 damage, I refer to as type 1A. And as you can see, the tooth has bitten down into the bone, but it hasn't caused much damage. It's really just lifted the surface of the bone. Type 1B, as you can see here, the tooth has bitten down into the bone, into the axis of the bone, leaving behind a deep groove with tapered ends and ridges and grooves within it. Here we have type 2 damage. As you can see, the shark has bitten down and has moved parallel to the axis of the bone, leaving behind a deep groove with no evidence of serrations. So basically what happens, it's like when you cut into a piece of meat, it bites down and moves straight across the bone. And this usually happens because sharks tend to propel themselves forward to take a bite and reverse. So this is the type of damage they leave. Here we have a group of parallel ridges and grooves. What happened here is basically the shark has bitten down but has lost its grip on the bone and its tooth has slid across the surface of the bone, leaving behind the scrape mark. And here we have an interesting thing that shows some behavior. So the shark has bitten down and has actually twisted its head to remove either flesh that was lying on the bone or near the bone or part of the tongue. And that is why you have this curvy linear appearance, showing the actual motion, implying actual motion of the shark's head as it takes a bite. What we found with this was that the teeth causing this kind of damage is serrated. And I'll get to the identity of the actual sharks in a little bit. But what we also found were these interesting bites. So as you can see here, you have a straight edge and a curved edge, and it actually pretty much looks like a smiley face. And there's no evidence of any ridges or grooves within it. And here we have a straight bite where the shark has bitten down and has moved across the surface of the bone. And here again, it has left no evidence of serrations. But unlike the previous bite, here you can see that the ends are also wide. Here we have the shark has actually bitten into the bone, but you can see some faint ridges and grooves. Now, based on the previous two bites, those bites were actually caused by sharks with unserrated teeth. And these faint ridges and grooves that you can see here are actually caused by damage to the tooth. So based on the number of specimens in the collection and being so numerous, a most likely shark causing the serrated tooth damage is a white shark, even though we do have megalodon in the collections, but more than likely it is white shark causing this damage. And the shark with unserrated teeth is more than likely mako shark, also found in our collections. The problem with sharks that don't have serrations on their teeth is that it's actually very difficult to state specifically and definitively which shark it actually is. We're basing it on the number of specimens that we found. What is also interesting about the specimen is that we have found two different types of sharks feeding on the same carcass. So we don't know if they fed at the same time, even though it's been documented off the East Coast where tiger sharks and great whites, less than 3 meters, were actually feeding on a humpback whale at the same time. We don't know if these white sharks were actually tolerating the presence of the other shark. When I was studying the seals, I also noticed damage that was obviously not abiotic damage, but was rather caused more than likely by terrestrial carnivores. So starting here, we have a pit. So basically a tooth has put pressure on the surface of the bone, breaking the surface of the bone and only pushing it in slightly. Here's another example where it is a little bit deeper, and another example where you have both shallow and deep pits. This material is currently part of a study that we've begun and hopefully will be publishing sometime in the future once COVID-19 lets us back into the collections. We also found punctual marks. So puncture wounds happen when the tooth puts pressure on the bone surface. But what happens is that the cortical bone is actually pushed all the way through into the damage. So it actually literally leaves a hole. This is probably one of my favorite specimens amongst the seals, because as you can see here, you have a canine on either end and probably the row of incisors. Here again on this femur, we have a puncture wound, and on the ventral surface of this vertebra as well. This specimen shows evidence of gnawing. So when an animal gnaws on a bone, it's actually gnawing on the exposed part of the bone, and it usually leaves behind a worked surface or a polished surface. What you see here are parallel ridges, a series of parallel ridges caused by porcupines actually gnawing on a seal tibia. These crenulations are most likely caused by hyenas, but I must point out the hyenas from Langebaanweg are considered to fulfill a role that canids do today. So they were mostly flesh-eating and probably weren't bone-cracking. Bone cracking candidates are the bear, Agrotherium, as well as the wolverine. So the damage that we see here, the vast majority, was caused by medium to large carnivores. And we kind of project a scenario not too dissimilar from this, where you have the carnivores maybe scavenging along the coast as they dead animals wash up, or they may be dragging them off higher into the river areas where their lairs are and they're feeding on them. It's also not too dissimilar from the situation on the Skeleton Coast in Namibia, where the hyenas and the lions and the jackals come down to the breeding colony to take young pups and animals and feed on them. So the artwork was produced by Adam Hartstone-Rose, which I'm really grateful for, and it kind of gives you an idea of what we think might have happened. So in conclusion, the Mio-Pliocene west coast of South Africa was affected by sea level changes and climate changes. The environments changed from embayed areas to rivers and estuaries to protected lagoons with offshore islands. There are at least 2 or 3 seals living off the coast. We know there are also breeding colonies at Langebaanweg. The cetacean fauna was related to taxa from the Mediterranean, the North Sea, the North Atlantic, the Eastern, North, and South Pacific. And young animals are present in the collections along the west coast. Lagoons were protected areas where the calves and cow-calf pairings and maybe juveniles were able to take shelter, and they had easy access to the areas. There's evidence as well of white sharks and mako sharks feeding on cetaceans on the west coast. And terrestrial carnivores were also feeding on seals along the coast. And a point that's also very interesting and to keep in mind is that between the marine avifauna and the seals, there's been a complete turnover in the seal and marine avifauna present along our coast today. Thank you very much. I hope you enjoyed that and it gave you some insight to the work I've been doing.
Update the stream. Thanks, Romala. I think everyone can hear me now and coming through as well. Last month we sort of had a little glitch at the end with the Q&A session where I forgot to get myself off mute. So hopefully everyone can hear me. So yeah, that was that's fantastic. Yeah, the bite mark studies are so detailed. Particularly with those sharks, it's incredible. It must have taken you ages to pull that all together.
Well, actually, it was actually quite funny. I was sitting looking at these things going, there aren't humans around, so nobody cut these things. What is this?
Yeah.
And I happened to come across a paper, fortunately, and I went, oh, wow, that actually is the same thing. So here we go. We got shark tooth marks. We actually have evidence of behavior in the fossil record, which is great.
Yeah, no, it's it's really high detail. I'm trying to get some questions out of our audience. I see everyone's a bit quiet. So hi to Mike Toy, and there's Maxine Davies out there, and Mark Murray is also in the audience, possibly Bruce Rubidge, though he says he's a resident in Graaff-Reinet at the moment. I'm not sure if he's on the talk or not. But if anyone else is out there, perhaps with a question, hopefully we can get someone. What is the sample size of the fossil record with these extinct seals?
Okay, so we have well over 3,000 specimens, but our biggest problem is that we have them as isolated elements. So we have very few. We have about, I think it's 7 or 8 skulls, 3 or 4 of which are very well preserved. So we can see fine detail with minimal reconstruction. But what we also need to do is actually to be able to analyze them, compare them to other taxa. We need the full picture. So we need to include post-crania as well as crania in our analysis, because that's what everybody else has been able to do because they have associated material. And that's why we started new excavations at Langebaanweg in the hope that we can find some associated material. Because and it's not such a far-fetched story to say there are 5 phocid seals living off the west coast 5 million years ago, because the exact same situation happens in South America. There's about 5 or 6 phocid seals living off the coast. But it was also of interest is what actually happened, and why is it that phocid seals today occur as visitors? So the odd elephant seal or leopard seal or crab-eater seal visits our coast, but they're not resident here. And one of the theories behind that is the lack of islands. So during the Pleistocene, when sea levels dropped again, you had all these islands that were offshore. So the archipelago of Langebaanweg. I mean, Table Mountain was an island at one stage. The Cape Flats was inundated by water, and all of that area was island. And what happened was that when the sea levels dropped and these islands disappeared, we had no more areas for these animals to pup or haul out, and they tend to move south. But what is even more confusing is that the temperatures were actually warmer then than they are today. So today we actually have more ideal conditions for them to live. So potentially it's the fact there is very little breeding areas for them to work with. That's why we've had the turnover.
Yeah, that's really interesting. So do you think they require some sort of mega breeding area, so the old Table Mountain Island, that habitat that is lost to them?
Yeah, well, the whole island thing. So even with the marine avifauna today are more likely to breed in islands than they are on a mainland. So the marine avifauna at Langebaanweg and Koeberg shows us breeding colonies as well as adults that were probably moving around the area. And we know that areas of Postberg, of Langebaanweg, there is evidence from guano, aluminium phosphate, which is from bird guano, which tells us these are actually islands 5 million years ago, and that's why there's all this really fantastic fauna living off our coast.
Fabulous, yeah. Well, we don't have any additional questions. It looks like you've answered
I've
everyone's...
shocked everybody, have I?
No, well, I think we've clearly got a very informed audience, and everyone hopefully enjoyed the talk. I think yeah, I think if without further ado, then I won't keep you up for the rest of the evening. But that was really fascinating, and I really enjoyed that. And I hope you have a lovely evening, and that
Thank
everyone who
you.
joined the talk enjoyed it. And yeah, we'll hopefully catch you all up in about a month's time for the next talk by Eric Fisher. We've already posted the talk abstract to the website, so you guys can all check it out. Sounds like a wonderful site that he's been working on. And Romala, I hope you are not a stranger. You can join us for the other talks
Thank you. I
during the
will
year.
do. I will
Yeah,
do. Thanks very much.
we really appreciate your coming this evening. And I wish I could give you a bottle of wine or a box of chocolates, but we'll have to convene
We'll
that
have to save that for another day.
for another day. Yeah, post-COVID.
Well, thank you very much for asking me to present my research, and it was a lot of fun to go back to some things I haven't looked at for a while.
Wonderful. Yeah, thank you so much. And
Yes.
yeah, have a lovely one.
Thank you, too. Bye-bye.
Bye-bye.